Okay, so now let's continue with conditional permutation first. So this part is conditional permutation. So what does it mean by conditional permutation? Obviously, there are conditions that the question wants. So as you can see from the checklist here, we have 3 cases, which is together, not all together, and separated or never together. Okay, so let's see the first question here. 3 married couples have bought 6 seats in the same row for a concert. In how many ways can they be seated? Okay, so there are 6 seats, 3 married couples. So with no restriction, straight away kamu kena letak 6 factorial. Okay, which is 6 factorial is equals to 720. Okay, 3 married couples, obviously perempuan kahwin dengan lelaki, ada 3 lelaki, ada 3 women. Then they have bought 6 seats lah. Okay, so if the question said no restriction, straight away 6 factorial. Okay, the second question, if each couple is to sit together. Okay, each couple is sit together. So let's put this as 1, 2, 3, 4, 5, 6. Okay, 6 people, 3 married couples. Saya cakap 3 men and 3 women. So if the question said each couple is sit together, so we have men, women, men, women, men, women. Okay, or husband, wife, husband, wife, husband, wife. So these people has to be seated together. Ini pun kena duduk sekali. Ini pun kena duduk sekali. Okay, so how are we going to rearrange this? Bukan rearrange. How are we going to arrange this? Okay, so antara 2 man dengan woman ni, dia boleh bertukar tempat, right? Dia boleh tukar tempat. So that's gonna be 2 factorial. Okay, ingat kalau dia boleh tukar tempat 2 orang, dia jadi 2 factorial. Or 3 orang, dia boleh jadi 3 factorial. The same thing with the second couple. 2 ni boleh tukar tempat. Okay, woman boleh duduk sebelah kiri, man boleh duduk sebelah kanan. And that's going to be 2 factorial as well. And the same thing for this couple. And that's going to be 2 factorial. Okay, tapi belum cukup lagi. Okay, you have 1, 2, 3 set couple. Okay, sekali, ini sekali, ini sekali, ini sekali. Nampak saya buat 3 bulatan dekat situ. That means you have 1, 2, 3. Antara 3 pasangan ni, dia boleh bertukar tempat. Yang pasangan nombor 3 boleh duduk depan, pasangan nombor 1 boleh duduk belakang, pasangan nombor 1 boleh duduk tengah. Okay, so there are 3 ways of arrangement. So what are you going to do is we are going to multiply by 3 factorial. Okay, so put everything inside your calculator. 2 factorial times 2 factorial times 2 factorial times 3 factorial, you are going to get 48. Okay, so that's how it is. Okay, kalau dia kata together, sekalikan buat bulatan apa yang together tu, kira yang dalam berapa factorial, kira yang dalam, and don't forget you have to include 1, 2, 3. Okay, so we are going to see this type of question lebih banyak lah later. If all the men sit together to the right of all the women. Okay, the question said to the right, so only one way. Maksudnya yang lelaki tu hanya duduk di sebelah kanan sahaja. Okay, let's see. Kita ada 1, 2, 3, 4, 5, 6 seat. Okay, so men duduk together on the right. 1, 2, 3. Right sebelah sini kan. 1, 2, 3. Okay, and therefore we have a woman, 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 woman. Okay, men sit together. Bila dia cakap together, apa yang kamu kena buat ialah kamu kena circlekan dia. Circlekan dia, consider this as 1. Okay, consider that as 1. Okay, so what we are going to do here is yang ini tak boleh duduk sini. Okay, tak boleh duduk sini, tak boleh duduk sini, tak boleh duduk sini. Dia mesti kena duduk di sebelah kanan of all the women. That means the woman has to be seated together as well. Okay, sebab dia ada cakap to the right, so ini kena duduk sekali jugalah kiranya. Okay, faham ke? So now what we are going to do is yang men 1, 2, 3, men 1, men 2, men 3 boleh bertukar tempat. Ada 3 tempat, so that's gonna be 3 factorial. Okay, 3 factorial. The same thing as the woman here. Woman 1, woman 2, woman 3 boleh bertukar antara 3 tempat. So that's gonna be darab dengan 3 factorial. Okay, boleh tak kita nak kira ini 1, 2? Tak boleh, okay? Tak boleh. Macam yang ini, yes, boleh. Sebab the question doesn't say that this couple has to be seated on this side, okay? So, kamu boleh tukar. This couple boleh sit on this side, boleh sit on this side. But for question C, the question said man must be seated to the right of all the women. So, tempat dia memang kat sini. Bulatan ni memang kat sini sahaja. So, you cannot multiply by 2 factorial. So, the answer is only 36. Okay? Right. So, let's see example 14. There are 10 students, out of whom 6 are females. How many possible arrangements are there if they are arranged in a row? Okay? No restriction. All 10 students arranged in a row straight away. 10 factorial. Okay? Equals to 362, 8800. Okay, now let's see. Question B. Males always sit on one side and females on the other side. Okay? Okay, so kita susun dulu. Kita ada 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 6 are females. 1, 2, 3, 4, 5, 6 females. Okay. So, kita buat bulatan. 1, 2, 3, 4, 5, 6. So, these are the females. Okay. Females. Okay. And the question doesn't say it on right hand side. Dia kata on one side. Okay. On one side. So, it's either this female can be seated on the left. So, that means this males ni pun kena duduk together juga sebab dia kena duduk sekali. Always sit on one side. Males always sit on one side. Females on the other side. So, this is the male. Okay. So, macam soalan tadi. Okay, let's see. Dalam female ni, antara 6 orang ni boleh arrange together. So, that's going to be 6 factorial. Yang males ni, antara 4 orang ni boleh bertukar tempat. 4 tempat. So, 4 factorial. Okay. So, now, this is considered as 1. And this is considered as 2. So, can these 2 be arranged? Boleh tak yang female duduk sini, male duduk sini? Boleh, sebab the question only said that male on one side, female on the other side. There's no specific side yang dia boleh duduk. Kalau macam soalan ini, dia kata to the right. So, male hanya duduk dekat sini sahaja. Okay. So, for this one, you can darab by, multiply by 2 factorial. Sebab female boleh duduk sini, male boleh duduk sini. So, dia consider 1, 2 ways lah. So, that's gonna be equals to 3, 4, 5, 6, 0. Okay, boleh lagi sekali. Kita ada males always on one side, females on the other side. Okay, 6 factorial datang daripada 6 orang females dekat sini. 4 factorial, kita ada 4 arrangement dekat situ. 2 factorial is for these 2 groups of people. Okay, so let's see example 15. In how many ways can 4 girls and 5 boys sit in a row if the boy and girl must sit alternate to each other? Okay, if the boys and girls must sit alternate to each other. So let's put this as boy first. 1, 2, 3, 4, 5. Okay, boy, 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 boy. Okay, the question said alternate. Okay, alternate tu apa? Bersilang lah. Bersilang. Okay, so you only have 4 girls dekat sini. Only have 4 girls. So, kita susun. Mungkin girls tu akan duduk dekat sini. Okay, mungkin girls akan duduk dekat sini. Mungkin girls akan duduk dekat sini. Mungkin di sini. Mungkin di sini. Okay, boleh tak di sini or di sini? You only have 4 girls. Okay, only have 4 girls. So, what we have to do, so yang boys 1, 2, 3, 4, 5 boleh bertukar tempat. So that's gonna be 5 factorial. And the girls also is gonna be 4 factorial. And that's gonna be 2880. Okay, so that's it. Example 16. 4 sisters and 2 brothers are arranged in a straight line for several photographs to be taken. How many different arrangements are possible if there are no restriction? Okay, straight away, if the question said no restriction, apa yang kamu ada, which is 4 sisters and 2 brothers combined together ada 6. So that's going to be 6 factorial. 720. Okay, now, the 2 brothers must be separated. So, kalau kamu tengok dekat checklist ni, bila dia kata separated, the keyword here ialah di celah-celah. Okay, celah apa? Celah, tahu tak celah apa? Okay, di antara lah, macam alternate tadi sebenarnya. Okay, let's see. The two brothers must be separated. Kita nak dua brothers separated. Kita ambil apa yang tak separated tu, which is 4. Okay, the sisters. Kita susun the 4 sisters first. 1, 2, 3, 4. Sisters. Okay. So the two brothers must be separated, which means dia tak boleh lah duduk sekali kat sini. So dia akan kena duduk di antara lah. Okay, this is the space yang dia boleh duduk. The two brothers. Okay. So sebab tu saya cakap di celah tadi. So the brothers boleh duduk sini, boleh duduk sini, boleh duduk sini, boleh duduk sini, boleh duduk sini. So ada berapa banyak tempat dia boleh duduk? 1, 2, 3, 4, 5. 5 tempat. Okay, before that, the sisters, 1, 2, 3, 4 sisters arranged together, there's going to be 4 factorial. Okay, so this is for the sister. Darab dengan, ada berapa banyak tempat untuk the brothers? 1, 2, 3, 4, 5. 5. Brothersnya ada berapa? 2 sahaja. So that's going to be 5P2. Okay, space P, berapa banyak brothers kamu ada? Okay, so that's going to be 4 factorial darab dengan 5P2 is 480. Okay, so when the cousin set separated, apa yang kita akan buat ialah tengok di celah-celah. Okay, apa yang dia nak diseparatekan tu berada di celah-celah. Okay, kita ambil apa yang dia tak nak, kita susun dulu, and then apa yang dia nak diseparatekan tu, kita tengok berapa banyak space ada, P dengan berapa banyak yang kita ada. Kan confuse ke kat situ? Okay, tapi tak apa, as you do more exercise, kamu akan faham lah. Okay, so let's see the last part, permutation where some objects are repeated. Okay, some objects are repeated. Let's see. The number of permutation of an object comprising of R1 identical objects. So the keyword here is identical. Okay, identical objects. So this is the formula. And factorial over R1 factorial, R2 factorial sampailah habis. Okay, what does it mean by that? Let's see example 17. How many different permutation can be made using the letters of the word bizarre? So kira berapa banyak huruf bizarre? Ada 6. 7. N is equals to 7. Ada berapa? 1, 2, 3, 4, 5, 6, 7. Okay, but as you can see from here, R di situ ada 2. Okay, ada 2 R. That means your R kecil sama dengan 2 lah. Okay, ataupun kita boleh letak R is equals to 2. So how are we going to solve this? Is actually 7 factorial. Yang di repeat tu, kamu kena bahagikan. Bahagi by 2 factorial, and that's going to be 2520. Okay, so ini ialah apa yang di-repeatkan. Okay, so if ada repeated object, you have to divide. Okay, ingat repeated object kena divide, repeated object kena divide. So now, let's see. This one, ada 2 T dekat situ, and kita is equals to 5. So T dekat situ ada 2. So how are we going to solve this? And O pun ada 2 sebenarnya. Ada 2 O. So apa yang kita kena buat? N factorial, which is 5 factorial, bahagi dengan 2 factorial, 2 factorial. Okay, 2 factorial represent O, 2 factorial represent T. Okay, ini untuk T, ini untuk O. Which is kat sini the answer is gonna be 30. Let's see, mathematics. N kamu is equals to 11. Apa yang berulang? M ada 2, A ada 2, T ada 2. So straight away, 11 factorial divided by 2 factorial, 2 factorial, 2 factorial, which is we have 498960. Okay, ini untuk M, ini untuk A, ini untuk T. So every repeated object you have to divide. So kalau kamu tengok dekat sini, soalan D, 4, F-O-U-R, there is no repeated object. So straight away just put as 4 factorial, which is equals to 24. Okay, so yang lain boleh buat sendirilah. This is the answer 151,200, 5200. Kejap saya tengok balik. 12 factorial. Two factorial times 2 factorial times 2 factorial. Sorry, 5, 9. Tak habis lagi. 5, 9875200. Okay, so that's the answer for G. Okay, boleh tengok sendiri apa yang berulang. Okay, let's see. Example 18. In how many ways 3 red, 4 blue and 2 green pens can be distributed among 9 students seated in a row if each student receive 1 pen? So the repeated object yang sama sebenarnya, ada 4 blue, 3 red, 2 green pens. Objek yang sama. So what do you have is n is equals to 3 tambah 4 tambah 2, that's gonna be 9. Okay, total pen is 9. Okay, red pen ada 3, blue pen ada 4, green pen ada 2. So that is the repeated object. Okay, so how are we going to calculate this? Is simply n factorial divided by 3 factorial, 4 factorial, 2 factorial. And that's gonna be 1260. Okay, so now lain sikit. In how many ways of the possible permutation of the letters of the word adding are the 2 Ds? So now the focus is on Ds. Okay, D kat sini. So 2 Ds are together. Okay, 2 Ds are together. So kalau kita susun dekat sini, kita ada 1, 2, 3, 4, 5, 6. Ini ialah A, D, D, I, N, G. Okay, the 2 Ds are together. Ingat saya cakap kalau together je buat circle. Okay, buat circle. So itu ialah 1. Okay, buat dia sebagai 1. Okay, and then you have 1, 2, 3, 4, 5. Okay, and straight away that's gonna be 5 factorial. 120. Okay, boleh ingat lagi sekali. The 2 letters D are together. So 2 ini kita sekalikan, dikonsiderkan sebagai 1. Kira yang tak together tu 3, 4, 5, 5 factorial. Okay, yes, supposedly kamu boleh darab dengan ini, antara 2 ni boleh bertukar, 2 factorial, right? 5 factorial darab 2 factorial darab 2 factorial. Okay, kita tulislah 5 factorial darab 2 factorial for the D's. Tapi ingat, D tu berulang, so you have to divide by 2 factorial. So straight away kita dapat 120, sebab ini akan cancel out. Okay, 2 factorial sebab 2D ni boleh bertukar tempat. 2 factorial sebab repeated object. Okay, okay, now separated. If the 2 D's are separated, so ingat apa yang tak diseparatekan kita susun dulu. So we have A, I and G, ada 4. A, I and G. A, I and G, ain. Okay, so dekat mana D tu boleh duduk? Separated di celah-celah. So D boleh duduk sini, boleh duduk sini, boleh duduk sini, boleh duduk sini, boleh duduk sini. Okay, so A, I and G, 4 letters. So that means 4 factorial. 1, 2, 3, 4, 5 tempat. Darab dengan 5 tempat. Nak letak berapa huruf? 2D. 2D. Okay, tapi ingat dalam adding ni, dalam word adding tu ada 2 huruf yang berrepeat. Okay, berrepeat pula, berulang. 2 factorial. Okay, so that's gonna be 240. Okay, lagi sekali saya ulang. 4 factorial represent A, I and G. 5 represent space. Berapa banyak space ada? 2 represent 2D. 2 factorial represent repeated D. Okay, so that is how you solve the equation, the question for separated. So now let's see example 20. How many different 10 letter codes can be made using 3 A's, 4 B's and 3 C's? Okay, so all this ialah apa yang direpeatkan lah. So that's gonna be total 10 letters, 10 factorial over 3 factorial, 4 factorial, 3 factorial, and that's gonna be 4200. Okay, now let's see example 21. This is the last example. Okay, ada satu lagi saya akan tunjuk. Okay, how many different arrangement are there for the letters of the word arrangements? Okay, arrangement. So let's see. Ada berapa huruf dalam arrangement? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N kita sama dengan 12. So apa yang diulang? 1, 2. Ada 2 A. So A ada 2. Lagi 1, 2. R ada 2. Lagi 1, 2. E ada 2. Lagi 1, 2. N ada 2. Ada lagi ke? A-R-E-N. Okay, that's it. Okay. So now the first question begins with R and ends with E. Begins with R and ends with E. So let's see, kita susun 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, ada 12 huruf dalam arrangement. So begins with R. So ini mesti kena R. Okay. So R ada berapa? R ada 2. Nak letak dekat berapa tempat? 1 tempat. So straight away dia akan jadi 2P1. Okay, ataupun 2 sahaja pun boleh juga, 2P1. Ends with E. So di sini mesti kena E. E ada berapa? 2. Nak letak dekat berapa tempat? 1. So that's gonna be 2P1. Okay, so the rest dekat sini. Ada lagi berapa huruf yang kamu ada? Okay, kamu ada 12 huruf. Kamu tolak 1, tolak 1, ada 10 huruf. Nak letak dekat 10 tempat. Okay, nak letak dekat 10 tempat. So that's gonna be 10P10 lah, ataupun 10 factorial pun boleh juga. So 10P10. Okay, so now let's arrange 2P1 darab 10P10 darab 2P1. Okay, jangan lupa ada repeated object dekat sini, and that's gonna be 1, 2, 3, 4. 2 factorial, 2 factorial, 2 factorial, 2 factorial. Okay, masuk dalam calculator. You supposedly get 907,200. Okay. Alright, so let's see the second one. The 2 letters E are separated. Okay, the 2 letters E are separated. So ada 12 huruf, kamu buang 2 E tu, so ada 10. So kita letak 10 dulu. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, ada 10. So that is 10 factorial. Okay, so the letter is are separated. Separated ialah di celah-celah ini. Semua ni ialah tempat untuk E. Okay, E kamu boleh duduk di sini. So ada berapa banyak tempat tu? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ada 11 tempat untuk E. E ada berapa? Ada 2. Okay, so that's gonna be darab dengan 11P2. Okay, bahagi dengan semua yang di-repeated. 2 factorial, 2 factorial, 2 factorial, 2 factorial. And that's gonna be 24948,000. Okay, next, 2 letters E and the 2 letters A are together. Ingat, kalau together terus letakkan circle. Okay, mesti letak circle. So tadi kita ada 12 huruf kan? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 2 letter E's. Kita tulislah E, E, A, 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 A. Okay, bila dia cakap together je, buat circle. Okay, 2 letter E kena together. 2 letter A kena together. Okay, so yang ni dikira sebagai 1, ini dikira sebagai 2. Okay, and the rest tu sambung kira 3, 4, 5, 6, 7, 8, 9, 10. So that's gonna be 10 factorial. Okay, ingat lagi sekali, kalau dia cakap together, ini satu circle dikira sebagai 1, 2 circle dikira sebagai 2, and the rest yang tak ada dalam circle kena kira 1, 1. So that is 10 factorial. Apa maksud dia? Sebab yang kumpulan A ni boleh duduk dekat sini, kumpulan A ni boleh duduk sini, kumpulan A ni duduk sini. So dia ada arrangement lah, 10 ways of arrangement dekat situ. Okay, and jangan lupa antara 2 E boleh bertukar tempat. Okay, so that's gonna be 2 factorial, and also the 2 A's can be changed. Okay, can change place, 2 factorial. Divided by all the repeated object, 2 factorial, 2 factorial, 2 factorial, 2 factorial. You supposedly get 907,200. Okay. Okay, so question D. The consonant letters G, M, T, S are together. Macam biasa, bila together je kena buat circle. Okay, kita ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. G, M, T, S. Bila together je buat circle. Consider circle tu sebagai 1. Okay, and the rest Sambung. 2, 3, 4, 5, 6, 7, 8, 9. So ada 9 tempat dekat situ. So that's going to be 9 factorial. So antara 4 huruf GMTS ni pun boleh bertukar tempat. So that's going to be multiplied by 4 factorial divided by all the repeated object. 2 factorial, 2 factorial, 2 factorial, 2 factorial. So that's going to be 554, 544, 320. Okay, saya pergi laju dekat sini. Saya harap kamu faham lah. Okay, sebab the concept is the same. Cuma nak fahamkan soalan tu lah. So last one, the 2 letters N occupied both ends. Okay, nampak tak? Setiap kali saya buat soalan, saya akan tulis 5, 6, 7, 8, 9, 10, 11, 12. Saya akan tulis berapa banyak huruf yang kamu ada dekat situ, berapa banyak huruf yang kita nak arrangekan. Okay, so that easier for us. So here the question said the 2 letters N occupy both end. Okay, maksudnya dekat sini N, dekat sini pun N juga. So N dekat situ, dekat depan dengan belakang is particular. Okay, remember this keyword particular. So bila dia cakap pasal particular, maksudnya memang dia berada di situ. So this is 1P1, this is 1P1. So there is no more repeated object there for N. Okay, so yang di tengah-tengah kamu ada 12 huruf tadi, kamu dah tolak 1N, tolak 2N depan dan belakang. So the rest dekat sini akan tinggal 10 huruf lagi lah. So there is no restriction for that. So ini akan terus jadi 10 huruf letak di 10 tempat. Okay, so 10P10. So how are we going to write this? We have 1P1 for N particular in front darab dengan 10P10 ataupun 10 factorial dengan N yang di belakang. Jangan lupa ada repeated object for A 2 factorial, for E 2 factorial, for R 2 factorial. Tapi jangan lupa yang N ni dah particular. Okay, so tak ada lagi repeated dekat situ. So you don't have to multiply by 2 factorial lagi. Okay, so here's you're gonna get the answer 453,600. Okay, 453,600. Okay, so that's it for permutation. So kita tengok satu lagi example dekat sini. Last example, a 5-digit number is to be formed from digit 3, 4, 5, 6, 7, 8. So ada 5 digit dekat situ with repetition. Okay, so boleh diulang. Ingat, keyword untuk with repetition ialah n to the power of r. Okay, how many ways can 4-digit numbers can be formed between 4,000 and 7,000? So here we have 4 digit. Dia nak 4 digit, so that is what you have to write. Okay, 4, 1, 2, 3, 4. Okay, 4 digit. Okay, so 4 digit numbers can be formed between 4,000 and 7,000. So 4,000 start with 4. Nombor apa yang kita boleh letak dekat sini? Dikatakan be formed between 4,000 and 7,000. So nombor apa yang kita boleh letak dekat depan? Obviously 4, 5, 6. Boleh tak nak letak 7? Kalau kita letak 7 dekat sini, paling kecil pun 000 dekat sini dia akan jadi 7,000. So the exit daripada 7,000. So the only 3 digits yang kita boleh bubuh dekat depan ialah 4, 5, 6. Okay, so there are 3 digits yang kita boleh bubuh dekat depan sekali. So that means 3 ways dekat sini. Okay, 3 ways. So the rest with a repetition, maksudnya 1, 2, 3, 4, 5, 6. Sorry, 6 digit sebenarnya. 1, 2, 3, 4, 5, 6 digit ni masih boleh lagi letak dekat sini. Contoh kamu dah letak nombor 4 dekat depan, masih lagi boleh ulang 4 dekat belakang. Contoh kamu letak nombor 5, masih lagi 5 dekat belakang. Boleh. Okay. But if the question said without repetition, kalau dah letak 4 dekat depan, 4 tak boleh duduk dekat belakang. Okay, that is one method lagi lah. Satu lagi cara untuk buat. So nanti itu kita akan discuss. So but now we are doing with repetition. So kalau saya letak 4 dekat depan, 4 masih lagi boleh duduk kat belakang. So that means we have 6 digits. We put 1 in front, belakang masih lagi boleh jadi 6. So that means we have 6 digit here, 6 digit here, 6 digit here, 6 digit here. So how are we going to put this? D3 darab dengan 6 to the power of 3. Okay, nampak? N to the power of r, 6 to the power of 3, which is there we get the answer 6 power 3, 648. Okay, 648. Okay. So next, let's see. The second question, 4-digit odd numbers. 4-digit odd numbers greater than 5,000. So ada 2 case dekat sini. odd numbers dengan greater than 5,000. So apa yang kamu kena buat ialah kamu kena pisahkan. Okay, kena pisahkan salah satu case lah. Okay, let's see, let's put this as 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, kita ambil yang greater than 5,000. Okay, obviously kalau dia cakap pasal odd numbers, okay, itu yang kita kena berbual dulu lah, odd numbers. Okay, odd numbers dekat sini kita ada 3, 5, 7. Okay, so 3, 5, 7 yang boleh diletak di belakang. 3, 5, 7. With repetition, kalau kamu dah berbual 3 dekat sini, 3 masih lagi boleh berada dekat sini. Okay, 3, 5, 7, 3, 5, 7. So there are 3 ways there. 3, 3, 3. Okay, so but we have the other case, greater than 5,000. So greater than 5,000 can be 5, 6, 7, 8. Okay, 5, 6, 7, 8. So kita boleh letak 5 dekat sini, 6 dekat sini, 7 dekat sini, and kita ada 8. 1, 2, 3, 4. 8 juga dekat sini. Okay, so here the same lah. 3, which is kita boleh letak 3, 5, 7. Okay, so now how are we going to do this is, ini 5 particular, memang satu je lah, kita akan letak satu je, which is 5. So the rest yang di tengah-tengah ni boleh repeat. Kalau kamu dah letak 5 dekat sini, kamu masih lagi boleh letak 5 kat sini, masih lagi boleh letak 5 kat sini. So that means all 1, 2, 3, 4, 5, 6 digit ni boleh diletakkan di tengah-tengah. So there are 6 ways kat sini, 6 ways. Same thing here, ini ialah 1 untuk 6 sahaja. Ni boleh letak 6. Ini 1, ini 6. This is only one ways, which is for 8. Ini 6, ini 6. So if we put this all together, it's gonna be 1 times 6 to the power of 2 darab dengan 3. Here we have 1 times 6 to the power of 2 darab 3. Ulang lagi, 1 times 6 to the power of 2 darab 3. 1 times 6 to the power of 2 darab 3. Okay, so here's you get the answer. 6 power 2 multiply by 3, we have 108. So here 108, 108. So 108 tambah semua, we have 432. Okay, so ini case dia lah, sama ada 5 dekat depan, or, ingat or ialah tambah, 6 or 7 or 8 dekat depan. Okay, so that is how we put the case. There you have two case. Kalau dalam cerita ini dia ialah odd numbers and also greater than 5,000. So saya separatekan all the 5,000, greater than 5,000. We have 5, 6, 7, 8. And then this one, odd numbers, ada 3. Okay, we can repeat because they kata with repetition dekat situ, kan? Okay, so that's it. How we do permutation. So this is your exit ticket. Panjang sikit soalan je, panjang, jalan kira dia senang sahaja. So you have to submit this on GC. I'll see you guys in the next subtopic, combination.